All right. Everybody here all right? All right, check, check. Sounding pretty good. Let's try that again. How's it going, everybody? Sweet. So I'm here today to take you on a little journey through the evolution and development of a tiny little transceiver that I call the micro Pixie. It's also earned the name the choking hazard from a few friends. And to really best explain the story, I need to tell you a little bit about myself and my history and background as a ham. So who is K6 ARK? Well, that's me. I'm Adam Kimmerly, and I became a ham in 2010. I'm a mechanical engineer by degree, but at this point in my career, I don't really get to do much engineering. So ham radio is a really great outlet for me to play and tinker and build. So is YouTube. At the top of the screen there, you'll see a screenshot of a 40 beer can tall tower that I created into an antenna. It took quite a lot of effort to build that and empty those cans, then weld them together. But those are the kinds of things that I like to do, just strange, fun antenna builds and projects. And it's really a great outlet for me. Some people might call me a social media influencer or something of that sort. I'm just a geek with a camera that likes to share my experiences and try to inspire others to do some of the same kind of stuff. I'm also a purveyor of antenna kits. The picture on the left there in the center is what you can build from my little matching units, which can be built as a 49-to-1 or other high impedance end-fed half-wave transformer, 9-to-1 UNN, or a 1-to-1 out of a kit of parts that I put together in a small package, and it makes for an exceptionally small antenna. And that's kind of a theme through my experience as a ham and operating in QRP. For me, QRP isn't just about low power. It's about lightweight, small, compact, and really ultra portable devices. The final thing there that is relevant to the story is my activity with search and rescue. I joined a search and rescue team in San Diego in 2005, and that's what inspired me to initially become a ham radio operator. So as I mentioned, I earned my license in 2010 after a member of the team decided he wanted to learn a bit more about ham radio and understand how our radios that we use on the team work for communications. So I became a tech. I was a tech for about 5 years. And then I eventually, I'd participate on local 2-meter repeaters, chatting with people during the commute. And eventually I picked up a Radio Shack HTX-10 and a great little starter radio for a technician, 25 watts. And I built a wire dipole, set that up on the porch, and kind of worked my way through figuring out how 10-meter propagation works, not hearing much for quite a lot of the time. And then one day I heard someone calling CQ on 28.4, and it sounded like a chipmunk. Didn't really know what I was doing, so I replied. And the kind gentleman there, Roberto N9NUQ, came back and said, "Hey, it sounds like you're a little off frequency." And I said, "Well, hey, I'm new to this. I'm sorry." And he coached me through on the air how to use the fine tuning knob on that Radio Shack to properly zero beat his frequency and complete the contact. So it was an awesome first experience to wet my feet and whet my appetite for getting into HF. Not long after that, I started studying for and earned my general class license, upgraded, bought a QRP rig, an FT817 that you see there in the photo as my first QRP rig. I started carrying that thing around to soda summits, activating soda summits on single sideband with an off-center fed dipole, bundle of feed line, a battery, and this ultra compact kit that I thought was super small and light, weighed 5 or 6 pounds. So as I mentioned, I'm an engineer and a mechanical engineer of all things. I avoided all this electrical stuff while I was in school because it scared the heck out of me. I couldn't see it and couldn't understand it. But I had an appetite for building and tinkering with things. So I purchased a Rockmite kit and I built that kit also kind of with the hope that it would inspire me to learn Morse code. I ended up built the kit and learned enough to make sure it worked and could send my call sign, but that was about it. And it kind of went by the wayside for a long time. I upgraded the FT817 to this little FX4, which is about a quarter, maybe a third of the size, lightened up the pack, and I was still operating sideband from summits with at least a slightly smaller kit, but it was still sideband. And there was one trip I was on with a friend, K6TW, his name's Tim, another SoCal soda operator, and we were up in the Eastern Sierra where there's no cell reception. We're in the middle of nowhere, and I had brought my FX4C, he brought a mountain topper, the MTR3B like you see me using here in the photo. And I attempted to activate. It took me about an hour to get those 4 contacts. I couldn't get a spot out. There was no cell reception. And he sets up his rig and starts operating CW with this mountain topper. And just like that, he's instantly spotted through the reverse beacon network. And he's got a dozen contacts in the log in a matter of minutes and still firing away. And I saw the size of that rig, looked at the size of my rig and the success he had. And I said, all right, it's time. I got to take the plunge and learn the code. So I did. I learned through the Farnsworth method that was mentioned previously. I would study while commuting, listening to code being sent in the car to and from work. And I got to the point finally in 2018 where I was proficient enough to start using that for CW activations from summits. And after about 5 years of building the Rockmite, I finally brought it out for some activations and began using it. And that's what this video is. So if you're able to. Click the link perhaps, if I'm able to maybe.
That opened a different window.
And it's not putting it in the.
It's not going to screen share it for me.
Would you like me to just narrate?
Well, again.
Shall we try to bring them up at the end?
I've got if you don't mind showing them at the end, that'd probably be a lot easier.
Yeah, we'll try to bring these video clips up at the end. So this is a fun one. It really shows the incredible performance of a simple transceiver like the Rockmite. There's a hint of sarcasm there. They're rock bound. They have a receiver with filtering as wide as a barn door. And this summit that I'm on is right next to Mount Wilson. And if you know California at all, Mount Wilson is a porcupine summit with some of the highest power transmitters all around. So when I turn this Rockmite on, as you'll hear in the video, I instantly hear this high-powered AM broadcast of some form of Asian elevator music that's just blaring in my ears. But I went ahead and tried and made contacts with the rock mite despite that fact. So as I mentioned, there was something really special about these simple transceivers that just drew my attention and sucked me in. And I think part of it, again, was that small size, that element of simplicity and minimalism that I got out of operating those little transceivers, even if they didn't perform really all that well. So I built more. The top left one there is a 49er transceiver, at least a version of a 49er. The top, and then the other, the top right and bottom left are the same. They're a Chinese version of a rock mite that you see out there that has a terrible keyer, by the way, but fits nicely in a mint tin with a little bit of trimming. And then I started building some Pixie transceivers, and the Pixie really kind of caught my attention just because it was really one of the simplest transceivers out there. 30 something parts. You can pick these things up for $4 or $5, maybe $8 or $9 now. And while the performance is negligible, they're just fun to build. And there's something special about those rigs. Here's the schematic of the circuit. There's not a whole lot to it, as you can see. And if you've built one, I'm sure you're familiar with that. So I started thinking, how can I make this even smaller? How can I trim the fat further and make this Pixie into even a smaller transceiver? So I took the board, it's a little, I don't know, 1 3/4 inch square, and I put it up against these various mint tins I had. This is the one in the photo there, and it almost fits. You have to trim the corners where the mounting post holes are located, and I took a Dremel and trimmed the corners and shoehorned it in there, along with the straight key here, shim stock that makes up a straight key. I put a DK3 IT tiny SWR meter in there, and I actually built the NFET halfway 49-to-1 matching transformer into the box as well, insulating the binding post from the case with a little nylon washer. And so all you have to do is add 66 feet of wire or so to this, and it's a functioning transceiver. And then of course a battery, you got to give it some power as well. And then I've got a headphone jack there for the earbuds. Well, clearly this is not small enough. So how about trying to cram this same PCB into an Altoid Smalls tin? Obviously not going to fit. So I got more creative and more aggressive with the Dremel tool, and ended up trimming off about 1/3 of that board. And I found that, if I really look at this thing, I've got mounting points for some TRS jacks, the headphone and key jacks. I don't really need those. I'll just solder directly some pads on the board. I don't need an antenna jack. I'll just solder directly to the board. So that's what I ended up with down here in the bottom right, this Altoid Smalls Pixie. And this one also had some sort of add-ons to it. The straight key here is actually the lever. A lot of people think this micro switch here is actually the straight key, but it's not. That's what turns the rig on and off, because underneath the board here, I crammed in 3 100 milliamp hour lithium polymer battery cells as a 3S LiPo. There's a charge port on the outside of the case right here. And this one has an SMA jack that sticks out as well for attaching an antenna. So this is a straight key. You simply press down on the end of the wire and it grounds out to the case of the crystal, which is grounded, and closes the circuit to transmit. So I'll go ahead and pass a couple of these around. You guys can send them through the audience. You're welcome to open it up and take a look. They do have batteries in them, so I would request that you don't press on the key lest we let the smoke out. So clearly those also aren't small enough. So how do I make this smaller? I've already cut away 1/3 of the board. I've had to rebuild a trace on the backside because I cut it off. And I'm getting more and more creative with how I cram these different these different pieces and accessories on. So this is a video we'll try to play at the end of operating one of the Altoids tin Pixies. So I reached out to some friends in a Soda North America Slack group that we've got going in our Workbench channel. And I had never designed a PCB before. I didn't know what the heck I was doing. But one of the guys on the Slack there, Jeff, AA6XA, an avid soda activator, had done some PCB development. So he gave it a try. He set up Eagle, AutoCAD's software for PCB design, and came up with this board that you see, the first one over from the standard Pixie board. He purchased some parts from a DigiKey bill of materials, broke them out into kits and sent one to me, kept one for himself and sent one to Rex, KE6MT. And each of us built the kit, put the radio, or put the parts on the board, and it didn't work. We confirmed that we had a functioning oscillator, we had very little transmit power, and it turned out that we made some poor choices in components and also had an error on the board. We used only surface mount transistors, which couldn't handle the power that we needed for the PA section, the final amplifier. So it kind of worked as a receiver once we sorted out the minor errors in the schematic that translated over into the board, but wasn't functioning yet. So it kind of dropped off the radar, and we didn't really work on it for about a year, and I wanted to get back to it. So again, I mentioned I'd never used Eagle before, so I learned the hard way. I downloaded the free version of Eagle, started tinkering, used my favorite source for learning, YouTube, and figured out how to put together a schematic and then build a board from it. And that's this second board here. And that was the first working version of the micro Pixie transceiver. You'll note that it doesn't have any through-hole components on it, as some of these later models do, other than the crystal. But ultimately, we ended up transitioning to a standard 3-pin through-hole transistor for the PA transistor to handle that extra power, and that seemed to be the most compact version. So since we didn't have those through holes, we swapped the 3 little pads for the SOT, what is it, 23-3, I think, size transistor, and just soldered directly to the pads the leads from the through hole transistor to actually get that one to work. And I plugged it in, hooked it up to the antenna. I could hear signals coming in, and I transmitted and listened on another radio nearby. I could hear a signal going out. So I knew I was putting some power out, put it on a QRP power meter and measured about 600 milliwatts of power going out. So I messaged Jeff and Rex and said, hey, I think I have a working micro Pixie. Can you get on the air and see if you can hear me? So they get on, we make that first contact with the two of them. And I figure, what the heck, I'll keep calling CQ a few times and see what happens. I'll probably not get anything. And sure enough, someone comes back to me. It's a gentleman in Lodi, 400 or so miles north in California there. Came back to my CQ, chatted with him for a bit. He gave me a 579 signal report. The band was in pretty good condition. And we had a rag chew for about 10 minutes just going back and forth. And it was incredible that this tiny little device was able to do this. I was blown away. But still, clearly that's not small enough. So I redesigned the board. I added the actual holes for the through-hole transistor for the final transistor, and progressively crammed the components closer and smaller and tighter onto the board until I finally made it down to this design here on the far right. And if you want to get a sense of scale on this thing, you all are probably familiar with Anderson power poles. Those are your standard 15, 20 amp Anderson power pole case connectors. So these transceivers are that size. I would like to get these back, by the way, but I'm going to pass a couple of these micro Pixies around. Hopefully we won't lose it along the way. If we do, I won't be heartbroken, but I would like them back.
So had a question from Zoom. Where is the microcontroller on the last one?
Let's see. So it's a two-sided board. Yeah, good question. It is a two-sided board, and the IC there is actually that's a LM386 audio amplifier, the standard Pixie transceiver. And I think that's an important note. I didn't really change much about the design of the Pixie. Again, mechanical engineer, electrons and radio waves, they're mostly over my head, but what I can do is mechanical design and cram things together and try it and see if the smoke comes out. And if it doesn't, then we win. So I did change a couple things on this. I eliminated the reverse protection diode that many people have added. I figured, you know, if I hook it up backwards, then I'll build another one. And I also removed the potentiometer for the voltage divider for the offset for when you key down, and just put two fixed resistors in there for that, and it functions well enough. So here's a picture of the boards from Eagle, the top and bottom components, and maybe this will help answer that question a little better. The LM386 is this 8-pin IC down here. Let's see, the three, you can see it on the blue side of the board, the three through-hole pins with the outline of the transistor there. I forget what those are, that case is called, but what he said. And then I've got pads up here for my connectors, my inputs and outputs. And those are spaced for your standard header pins to make it relatively easy to just attach some header pins and attach peripherals. And then my antenna output here, I added a couple of through holes and then one extra through hole so I could mount a FT20-43 size toroid for a miniature end-fed half-wave matching unit. And it does work. So this is a video of the activation, and hopefully we'll be able to play this at the end. Just one note, these are all these videos are on YouTube, and you can find them if you search my call sign, K6 ARK, and watch some of these. I'm sure some of you have already seen some of those videos, but there is a video of this little unit in action. And what you might see there is the little wire on there is actually the straight key that I use, just pressing down on and grounding out that piece of wire. So again, the video here, and in this screen capture, you can see the end-fed half-wave matching unit I was using for this SOTA activation, which is one of those FT20-43 toroids. Probably one of the smallest end-fed half-wave matching units around. So what's next? Clearly, this isn't small enough. So I'm going to go back a couple here. One thing that, 0402 components for the resistors here, and they are tightly packed. So I do assemble these by hand. I don't drink any coffee before embarking on an assembly effort. I use solder paste and hot air and fine point tweezers and a needle. I've used 3904s and 2222s, and both seem to work fine. Haven't had an issue with either one. One thing I have noticed, and I'm not sure which component I'm pushing too hard, but I do have a little bit of frequency drift as I operate these. I end up getting about 850 milliwatts out of this, so I know it's pushing that stuff pretty hard when I'm running about 12 volts of input. I would presume pulling back the power would probably help a little bit with that, but you'll actually notice that in the videos where I'm operating it, you'll hear the frequency drift just a little bit. Yeah. No. No, I wasn't able to cram that in there. But you know, maybe as a next edition here. So what is next here? Got to find my notes and make sure I don't miss anything. Let's see here. So what's shown in the photo there is even smaller than a 0402. That's a 0201 component. And I actually drew up a board and have one mostly assembled here. It's about half the size of what's being passed around. And I don't know if it's going to work or not. I've got a little work left to do on this. So it's possible that I may be able to get this to work. We shall see. I don't remember. I think they're 6 mils, if I remember correctly. I think I left it as the standard in Eagle, which I think is 6. What's the trace width on these boards? I believe it's 6 mil. So perhaps that's an option. Go a little smaller. Yes.
From the Zoom, someone asked, are the Gerber files available for this micro Pixie?
So I have not shared the Gerber files. One of what's potentially coming next is to manufacture these and try to sell some built ones. I have some tweaking I want to do before I do that. But there's also been some questions about perhaps just buying a board from me and purchasing some parts from a BOM and building a kit. I think most people will look at that and are familiar enough with the size of those components to recognize that that's probably not something that they want to do. If you really think I would say if you have experience building surface mount boards with tightly packed 0402 components, reach out to me and I'll work with you on getting you a board and getting you the bill of materials. And you're welcome to try to build one. Other what's next elements, well, just like the regular Pixie, and since I used the same components, the low pass filter on this is not really sufficient for knocking down the second harmonic spurious emissions to FCC required levels. So I want to do a little bit more tweaking, add a component or two to the filter. And if I'm going to sell manufactured ones, I would at least like them to meet the FCC requirements for spurious emissions, even though it's such a low power device and it's technically really a kit radio at that point. I think it's just the right thing to do. Let's see here. A 3D printed case, that's another thing I will likely be looking at and pursuing for this, possibly with integrated slot for a battery and or a straight key involved on it. And then one of the other things I've projected with are capacitive touch keys and capacitive touch circuits that can be integrated into things like mountain toppers and such. And an idea I had was to add, rather than having that mechanical straight key on the board, to add a few more components and have a capacitive touchpad on the board as a straight key. Slightly increase the size. I know it's a compromise, but perhaps provide a little more usability there.
Good luck with that.
So that concludes my slides. Hopefully we can get some of those videos to play. Before we do that, I want to say a big thanks to David for having me here. Andy, I believe, is it Andy? Yes, Andy for running the show, and all of you that organize this event. This is awesome. I've never been here before, and I will certainly strive to come back. And then finally, thank all of you for coming along on the adventure through my adventure in building the Micro Pixie. So I'll be happy to take any questions. We've got plenty of time here. So right back there. So yeah, I've been generally running them with a 3S LiPo cell. So it's going to range between about 12.4 fully charged down to 10 or low to mid 10. They do run at lower voltages fairly well. So I think I think they'll even run effectively at just a 2S LiPo, even with a little bit lower power output.
Just for our identification, you are
Yes, and you know, I know my days are numbered as far as building this size boards with this size component. I'm 42, and currently I'm actually able to still build the 0402 size boards without a magnifying glass. I certainly need it for the 0201. Yes. We'll see if I can still say that by the end of the year. Right here.
First off, you go up on top and mouse these things. I don't know how you dodge other QRP guys throwing their radios at you. But seriously, my question, a couple of the examples you had the matching transformer for an in-fed half-wave as part of it, and you've been kind enough to pass around some of the smaller one with the header pins I didn't see on there. Your adventures with finding something that small to effectively use on these little guys with that antenna. That's one of the most amazing feats of engineering I've seen in was getting all that business on there. You talk just a tiny bit about those.
Yeah, fair enough. So one of the things I'll start with, and that I would point you to, are have you seen the antenna matching unit kits that I I sell? Okay. Yeah. So yeah. Oh, cool. Thanks. So my website is just k6ark.com. And I came up with this original idea. I had a coaxial crimp and solder BNC connector that has kind of a little post that sticks up in the middle, and you solder the wire down into the pre-installed pin. And I was looking at the thing and I said, you know, I use these FT50-43 toroids for end-fed half-wave matching units for 5 watts. And I put them in these little plastic cases. And one day I had one of the BNCs and one of the toroids, and I just set it on top of the BNC, and I was like, hey, wait a minute. That'd be pretty cool. So I actually put out a video, 3-4 years, maybe 5 years ago, showing a way to build a 9-to-1 and a 49-to-1, either way, with those solder and crimp connectors and those little toroids. And it was pretty hard to do. It wasn't very user friendly. And eventually a friend of mine, Matt N7MCB, said, hey, you know, I got this idea to use a PCB and simplify this task using a PCB mount BNC connector, you know, that has little 4 PCB ground pins and a center pin. You just solder them into the board. So so I took that idea and ran with it, made my own board that has some little more features to it, some strain relief holes and things, and put those together into kits with the hope of making it easier for people to be able to build that type of antenna matching unit. When I run portable, I very rarely carry a feed line. I just attach an end-fed half-wave directly to my radio, and I don't even use a counterpoise. I am the counterpoise when I'm holding the radio, and that works well enough. I even work plenty of DX with 5 watts. So I know I'm compromising a little bit of performance there, but regardless, these little matching units work really well. And I kind of just took that concept a little further and said, okay, what else can I cram into this box? And honestly, I've thought about doing it with the mountain topper too. Just putting the matching unit inside and just carrying the wire on the outside, because that just makes an even smaller, more self-contained kit. So haven't done it yet. Maybe it'll inspire one of you to give it a try, but it's kind of a fun way to operate.
The little 1 centimeter one that you're working on, how are you going to work the power out for that? I mean, I think it's kind of hard to get 5 watts out there.
I'm not. Oh yeah. You mean for the antenna?
No, I'm talking about the transistor.
So you're talking for the nano Pixie version. Yeah, I don't expect 5 watts. So I get about 850 milliwatts out of the big one that's being passed around. And I'm knocking the power back, the input power back on the nano and I'm using just the SOT 23-3 transistors again. So I'm not expecting more than like 100 milliwatts max out of that. Yes.
Do you have to do anything special with workhouses to get them for small units? Do you have to gang together yourself, or?
Yeah, so I typically don't gang them together myself. When I've ordered the purple boards, all pretty much come from Osh Park. That's a pretty familiar, readily accessible, very affordable manufacturer for especially for small boards and small runs. For larger quantities, like for the ones I use for the end-fed half-wave matching units and things, the kits for the antennas, they're 1/2-inch diameter circles. And I just put in my comments to the manufacturer, panelize as necessary. I'm happy to do the depaneling. So, and they do it, and it's super simple. So, yeah. Yeah, so for the kits, I use 26 gauge wire. I find that is a nice size that makes it relatively easy to build. It doesn't break too easily, which is a nice bonus, and it's not so big that it doesn't fit. The 26 gauge wire can handle a lot more power than just 5 watts, but I find that to just kind of be a good usable size. Any other questions? Yeah, let's see if we can get the videos to play.
Help me out here, because so 3:39 to
Yep.
start.
That's where I want to start.
Okay. We may not need that. Hang on just a second. Let me go back.
So this one is the peak up near Mount Wilson, where I was getting that that interference with the rock mite.
Doesn't matter which frequency I'm on. But what the hell? Let's give it a shot. I'm just listening to Asian elevator music.
So you can see I've added that capacitive touch key to the rock mite as well.